Alright guys, welcome to this page of the notes, and again what we're going to do here is we're going to go ahead and take a look at finding an inverse function. Once again, I explained to you kind of the notation that we're going to use for finding an inverse function. It's very, very important that you use this notation. And the description I gave to you on the previous page, I just re-described to you here, but now instead of it being a relation, we're talking about a function. So if you're given a function f of x, what I'm telling you is the inverse function of f of x. So you're given the function f of x, its inverse would be 1 over f of x. But we don't want to call the function 1 over f of x because it just looks a little weird and we don't like doing that. So I use that property of exponents to bring that f of x back to the numerator by changing the sign of its power. So it is now f to the negative first power of x. That means inverse. By definition, that is the inverse function, and so that's what we're going to call our functions. But it depends on the name it's given. If you're given the function g of x, if you're given the function g of x, then the inverse would be g to the negative first power of x. If you're given the function n, the inverse would be n to the negative first power of x, right? So whatever they've named the function, you keep the same name, you just put it to the negative first power once you've found its inverse. Now let's talk about how you go about finding that inverse function. And here's how you do it right here. You will exchange or switch the domain and the range values, which is exactly what we did for the relation, switching the x and the y. So at some point when finding the inverse function, you're going to switch the x and the y, and I'll show you how to do that actually in a very simple, it's just a 4-step process to find an inverse function that's very, very easy to follow. So let's go ahead and do that. Just keep in mind, we're going to be switching the domain and range values, switching the x and y's to find the inverse function. Here's how it's going to work. I've given you a function, f of x is equal to x plus 6 divided by 2. I'm going to ask you to graph both the function you've been given, f of x, and I want you to find the inverse function as well as graph it. So we're going to be graphing both functions, but first we need to find f inverse. So here we go. We're going to start off by doing it this way. Step 1. You need to replace f of x with a y. Remember, f of x means y, but if I'm going to switch the x and y's, I need there to be a y. So, replace f of x with y. So here we go. My new function is y equals x plus 6 over 2. Right? That's step 1. This is the function I was given. It's called f of x. I am going to replace that f of x with a y, so now I have a y in there. Why did I put that y in there? I know, you do lots of y's. Step 2, switch the x and y. Okay, so the x and y's are going to switch places, and now I have this function, which is x is equal to y plus 6 over 2. Y plus 6 over 2. Okay, so step 1, replace the f of x with a y so that I have a y. Step 2 was to switch the x and y just like we did with the relation, right? To find the inverse relation, we switch the x and y coordinates. I don't have coordinates here. I have a function, so I just have to switch the x and y variables. And now step 3, right, in order to graph this guy, well, step 3, I need this function, right, my new function, to be solved for y, so I can graph it. So step 3 is solve for y. So let's do that. Okay, first thing I'm going to need to do to get this y by itself is move the 2. So I'll multiply the 2 to the other side. Let me show you all these steps. X is equal to y plus 6 over 2, which means 2x is equal to y plus 6. Subtract the 6 to the other side, and you get y is equal to 2x minus 6. Now, here's the beauty of this. Please notice y equals 2x minus 6 is already in slope-intercept form. Y equals mx plus b, right? So that's going to make our job, our life, so much easier when it comes to graphing. That's my y-intercept. That's my slope. We'll just throw it on a coordinate plane and we'll be all set to go. However, you have one more step to go, right? Because I need to be able to tell you, right? There has to be some way for me to tell you, hey, by the way, this is an inverse function. And here's how you do it. Step number 4. Replace y with f inverse of x, right? Use that notation, f to the negative first power of x. So here's what I've got. My original function, if you remember, you were given f of x is equal to x plus 6 divided by 2. This was my original function. You just found the inverse function, this guy right here, which we will call f inverse. F to the negative first power of x, the inverse function, the inverse operation is this, 2x minus 6. And it should make perfect sense. What you're doing here in this guy, oh, let me box that one because that's one of my answers. Actually, that is my main answer. That's my inverse function. Think about what you're doing. When you plug in a domain value, right? When you plug in a value for x, what do you do to it? Well, you add 6 to that number and then divide by 2. So if you take some number, pick any number you want to, right? You're just picking a domain value, choose any value, plug that number in there, you add 6 to it and divide by 2. Well, how do you undo that? How do you undo what you did to get back to the original number? Well, you would do the reverse operations. So you take that number, you multiply it by 2, and subtract 6 to get back to what you originally had. It goes back to that idea where we were doing the conversions with units, going from miles per hour to meters per second, and then back from meters per second to miles per hour. You just undo what you previously did. That's exactly what we've got going on here. F of x does something to a number. It adds 6 and divides by 2. So my new function, my inverse function, undoes what f of x did. It multiplies the number by 2 and then subtracts 6 to get you right back where you started. They're inverse functions, inverse operations. And now all we need to do is graph both of them. Okay, so what I've got here, first I'm going to need to do a little bit of work because the f of x I was given is not in slope-intercept form, but it's very, very easy to do. All you have to do is split it up into 2 fractions. Actually, here, let me do that right down here so I have plenty of space to show my work. You were given f of x is equal to x plus 6 divided by 2, which I'm just simply going to write as f of x is equal to x divided by 2 plus 6 divided by 2, which means f of x is equal to 1/2 x plus 3, and this as well is now in y equals mx plus b. All right, so there we go. I've got both of the functions that I'm going to graph. I have my inverse function right here. This is my inverse, 2x minus 6, right? That's my inverse. Y equals mx plus b, easy to graph. And the function that you were originally given, your f of x, which I have put into slope-intercept form, y equals mx plus b, so that I can easily graph that one. We'll do them both in different colors. I'll do my original function. I'll graph that one in red. I'll graph my inverse function in green. So my original function has a y-intercept of 3 and a slope of 1/2. Y-intercept of 3, slope of 1/2. 1, 2, 3. Make sure I have the right color. I was going to do red. Yep. All right, so a y-intercept of 3 and a slope of 1/2. That means up 1 and over 2. Up 1 over 2. If I didn't want to go up 1 and over 2, the exact same thing would be to go down 1 and back 2. So down 1 and back 2, down 1 and back 2. And you just keep doing that. Remember, when you graph a function, make sure that you extend your line all the way through the coordinate plane that I've given you and put arrows on both ends so that I know you know that line just keeps going. It doesn't end. All right, fantastic. So that is my function, f of x. That was the original function you were given, f of x. So now I need to graph the inverse function that we found, and let's jump down here, take a look at it. My inverse function is 2x minus 6, which I'm going to graph in green. 2x minus 6, which means my y-intercept is a negative 6. My slope is 2. We can do that. All right, my y-intercept was a negative 6. 1, 2, 3, 4, 5, 6. There's negative 6. And my slope was 2. So that's up 2 and over 1. If you don't want to go up 2 and over 1, you could just as easily go down 2 and back 1. Again, make sure that you extend your line all the way through the coordinate plane and put arrows on both ends so that I know you know. That line just keeps going. All right, now that is f inverse of x. That is the inverse function, the one that you found by doing those 4 simple steps. Replace f of x with y, switch the x and the y, solve for y, and then replace y with f inverse of x, right? Really, really simple steps to find the inverse function. And hopefully you notice something interesting about the graphs, and it's actually this. Inverse functions are going to be symmetric. Simply means inverse functions are going to be mirror images across the identity function. Remember, the identity function is one of the functions I made you memorize back in chapter 2. It's one of our parent functions. It's this one. Y equals x was the identity function. And if you recall, the identity function is just simply a straight line that splits the first and third quadrant. It runs right through here. So, if you want a quick, easy way to check and make sure that you did things right, that your graph is good, all you have to do is just throw that identity function in there real quick. Make sure it's a dotted line because it's not, I didn't ask you for the identity function. It's just you checking your work, and take a quick look at it. If it looks like the lines you've graphed are mirror images of each other across that identity function, y equals x, then chances are very, very good that you did it right. If they don't look like mirror images across that line, then you probably made a mistake. Guys, that's how you find and graph inverse functions. Head on over to the next page of the notes and we'll try another example problem. I'll meet you there.